Chapter 2 Wave Motion. There are two broad categories of waves. These are 1. Mechanical waves. 2. Electromagnetic waves. 1. Mechanical waves. These are waves that propagate through a material medium. Mechanical waves require a material medium to travel through. The following are mechanical waves. A. Water waves. Water waves at the seaside transfer energy when they hit the shore to move sand and shingle up the beach. B. String waves. The figure below shows a wave on the string propagating to the right, and, as a hand wiggles to the left of the string up and down. C. Seismic waves. Earthquakes happen when two parts of the Earth's crust slide past each other suddenly at a fault. There are two main types of seismic waves. A. P wave. B. S wave. A. P wave. It is a primary pressure wave. It is a longitudinal wave similar to a sound wave. The speed of the P wave generally increases with depth in the Earth, but is slower in liquids than in solids. B. S wave. It is a secondary shear wave. It is a transverse wave. The speed of S waves generally increases with depth in the Earth, but is always less than the P wave and cannot travel in a liquid. The mechanical waves can further be subdivided into two categories based on the motion of the wave relative to the medium particles. These are transverse waves and longitudinal waves. A. Transverse waves. A transverse wave is one that which the particles of the medium vibrate in a direction perpendicular to the direction of movement of the wave. String and water are examples of transverse waves. B. Longitudinal waves. Longitudinal waves oscillate along the same line as they travel, transferring energy and information in the same direction. The particles of the medium vibrate parallel to the wave's movement. This motion includes areas of compression, where particles are bunched together, and areas of rarefaction, where particles are spread apart. Sound waves are examples of longitudinal waves. 2. Electromagnetic. Electromagnetic waves are disturbances made up of electric and magnetic fields. Electromagnetic waves propagate through space. Electromagnetic waves do not require a material medium to transfer energy. They can travel through a vacuum. Visible light, radio waves, infrared, microwaves, ultraviolet, radiation, X-rays, and gamma rays are examples of electromagnetic waves. A. Gamma rays have the shortest wavelengths and transfer the most energy of all the waves in the electromagnetic spectrum. Note, the gamma ray is generated in nuclear reactions. B. X-rays pass through soft tissue in the body but will be absorbed by bones. Note, X-rays are high-frequency waves that have great penetrating power and are used extensively in medical and manufacturing applications. Comparing gamma rays and X-rays. Gamma rays and X-rays have very similar ranges of wavelength and frequencies, and so have very similar effects. Their high frequencies mean they carry the most energy and are the most penetrating forms of electromagnetic radiation, so they can be most dangerous to human body tissue when the radiation is absorbed. Both are highly ionizing radiations. The key difference between gamma rays and X-rays is how they are produced. Gamma rays are emitted from the nucleus of an unstable atom during radioactive decay. This is a random process. An X-ray is generated by an X-ray machine when high-speed electrons collide with metals and lose energy. A. Radio waves and microwave communication. A system using electromagnetic waves to communicate must contain a transmitter to send a signal and a receiver to receive it. Terrestrial radio and TV signals are sent by radio waves. The radio waves travel through the air at the speed of light. The path between transmitter and receiver usually has to be a straight line with no large obstructions, such as hills and tall buildings. So the transmitters are placed on towers that may be hundreds of meters tall. Using a microwave for communication. Microwaves are used to transmit mobile phone signals. Microwave transmitters or base stations are placed on the masts of high buildings to provide better line-of-sight communication over long distances. Although most microwave signals are sent directly, some are sent from a transmitter to a receiver via a satellite. Microwave satellite communications are used for satellite phones and for satellite TV. Note, microwaves range in length from approximately 30 centimeters to about 1 millimeter. Dangers of electromagnetic radiation. When electromagnetic radiations enter living tissue, it is often harmless, but sometimes it creates havoc, harm. The effects of each type of radiation are based on how much energy the wave transfers. The higher the frequency of the radiation, the more energy it transfers, and so the more dangerous it is. For example, radio waves don't carry much energy. There is a low chance they will cause cell damage if they are absorbed. Whereas high-frequency waves like gamma rays transfer lots of energy, meaning they are much more dangerous. A. Heating and burns. Some wavelengths of microwaves are absorbed by water molecules them to heat up. Cells in the body contain lots of water, so being exposed to microwaves, e.g. from mobiles and wireless internet, can cause cells to heat up. There is a debate about if this is harmful. Infrared radiation is mostly reflected by your skin, but some is absorbed, causing heating. This can lead to burns if your skin gets too hot. B. Skin cancer and eye conditions. Ultraviolet is also absorbed by skin. It is a type of ionizing radiation, and when absorbed it can cause damage to cells on the surface of your skin, which could lead to skin cancer. It can also damage cells in your eyes and cause a variety of eye conditions or even blindness. C. Cancer and radiation sickness. X-rays and gamma rays are also ionizing, so they can cause mutations and damage cells too, which can lead to cancer. But they have even higher frequencies, so they transfer even more energy, causing more damage. This means that sometimes they kill cells entirely, which can lead to radiation sickness, which causes vomiting and hair loss.